It's like this is
Shut
a
up.
it's like this is a timeless classic called Big Iron. Okay, this was used in many pop movies in the '70s, and also it's a very original song written by him, and it's very just.
And unknown to many people, it's in the James Bond movie.
Yeah. This song is often referenced to the Wild West, and it's often used in movies such as, and then it lists every single movie it's used in.
And directors of all those movies.
It's like, this movie, this movie hit box office.
It's gonna play the entire movie.
It just tells you the.
No, it's not going to play the movie. It's going to read the script out to you.
All right, so heads up to you. I'll be sending a message on Remind so everybody's aware. But we will tomorrow. I should be picking up the materials that I need for our lab on Friday. Be sure and come prepared. It's going to be a lab like no other.
Okay.
Oh yeah, bomb. So that's what we want.
Does it have anything to do with the combustion? Are they with the vehicle? Is that because they're?
Yeah, technically.
Could you say it is the bomb, Mr. Hall? Would you say it's the bomb?
I will say this will probably be the most excited you all have ever been for a lab before.
Probably just want to blow something up. I know, I've been envisioning it.
I'll tell you what we're going to do. We're going to examine and observe the chemical changes that take place to a substance and make observations of how certain heated substances transfer energy over to find a state of equilibrium.
Yes, sir.
To
Sure. Not too bad.
Okay.
yeah, that sounds scientific enough. That's what we're doing.
I think this is where we.
If you
Oh yeah, combustion.
ever want to know what we're really looking at, become hungry. We're gonna make everybody's favorite camp.
And flip the page.
Seriously?
Make everybody's favorite camp treat.
Oh,
Are
marshmallow.
we having a s'more?
Make s'mores.
Just marshmallow.
Oh my goodness.
Now, let's make sure and get this right. If an administrator asks you, we are examining the transfer of energy from one phenomenon to another and how equilibrium is found between two
$40.
completely opposite temperature objects. Hence, a marshmallow we just roasted and a piece of chocolate. Which, I will tell you this, you're gonna call me nuts. Yeah,
You're crazy. man.
don't do Hershey's chocolate. Do a Reese's cup.
Whoa. That's genius.
That actually
You
sounds
know what?
really
I will call you
I-
crazy.
That sounds awesome.
You're a genius. Revolutionary, right there.
I promise you this.
I was upset at
You ever
first, but
eaten
that sounds
s'mores?
Hey,
good.
wait a minute, Mr. Hall.
That's the only
Are we
way.
gonna finish combustion?
There ain't much to add to it. You figure it out later.
Well, I mean, we didn't do we just wrote the name down.
I guess I want to have it.
Is it just whatever it wants to be? What's the thing for it?
Yeah, that's all. It feels unnatural to not have a thing for it.
All right, combustion reaction.
Is
We
that?
have a fuel source, which is always a hydrocarbon for our class, plus oxygen, and it always yields carbon dioxide
This is
and water.
complicated. This is not ABC plus D.
You see why I didn't want to put it up right now?
Yes, I don't like it. Take it down.
Bro,
Wait, hold on, I'll finish writing it. All right, you can take it down.
All right, so we're gonna go through synthesis reactions. Hear me out. What you're going to find, wow, that end is not connected. What you guys are going to find with the reactions is, I'll be honest with you, synthesis is a little difficult. Decomposition, in my opinion, is the hardest because they're special cases, okay? So synthesis, decomposition, are the two hard ones. That's why we start with them. We get the single replacement, and then we get the double replacements. In combustion, they're pretty easy. So we will spend a lot of time on synthesis and decomposition, and then you're going to feel like we just breeze through the other three. So, synthesis reaction, I want you to remember, it's A plus B goes to AB. Remember what this is that we're looking at. This right here is John sees Sally, thinks Sally's cute. Sally sees John, thinks John's cute. They exchange snaps. Next thing you know, they're snapping all fourth period.
Wait, with stop looking at me. With the example you
So-
used, like blowing the pink the smoke.
A plus B will go to AB. So there's certain different types of this. So the first one we're going to look at, first situation, are going to be elements with oxygen. So these are elements reacting with oxygen. So this is the first type of synthesis reaction we're going to look at. Very exciting, right?
Oh, yeah.
So the most common ones that you'll see with these are going to be metals. So first type of these are metals combined with oxygen to make metal oxides.
Lord. She's gonna love her PowerPoint, trust me.
So metals will combine with oxygen to make metal oxides, and a couple examples of these, okay? So you get an idea what this looks like. Let's say, for example, I take some magnesium, and I react it with oxygen, and I heat it. Don't worry about the triangle over the arrow, it just means I'm adding heat. I'll print you out and have you a nice little list so you can have it for whenever you go to college. But the metal combines with the oxygen to make a metal oxide. Here's the key. What's being produced? Metal oxides. So it's a metal. What metal am I dealing with? I have magnesium, that's my metal. So what this will form is magnesium oxide.
Holy moly.
So we don't have to use the stock system.
Because magnesium is in the second column.
Oh, is it?
Yeah, not manganese, magnesium.
That's so.
I hate manganese.
Manganese wants to be
Yeah,
magnesium.
manganese is magnesium is everything, manganese is not.
So, whenever you do this, this is not the, I do not want the word equation, I want the actual chemical formula equation. So, magnesium, Mg, plus oxygen, look at oxygen, it's O2, because it's a diatomic, will react
True. True.
to make magnesium oxide. If you look at magnesium, magnesium's in the second column, so that's Mg2 plus, oxide comes from the 16th column, it's 2 negative. It is a 1-to-1 ratio, or you can bring the 2 down for the magnesium, 2 down for the oxygen, get the Mg2O2. Realize we can simplify it just to MgO. It's not good enough because it's not balanced, so we have to balance it. So we write down the elements we have. I have magnesium and I have oxygen. Magnesium, oxygen. I have 1 magnesium on the reactant side, 1 magnesium on the product side. 2 oxygens on the reactant side, but only 1 oxygen on the product side. So remember what we got to do? Magnesium's first, they're balanced. Go to the oxygens. I have 2 on the left, 1 on the right, so I can stick a big 2 right there in front of the magnesium oxide. That changes the magnesium and the oxide. I do have 2 oxides now, but I also have 2 magnesiums,
This is so sad.
which means I gotta rebalance. So now I go to the magnesium, stick a 2 here in front of the magnesium, and we're balanced. Questions? I can do this with transition metals, but what I do is I tell you the charge of it. Since we have to follow along with and go with the stock system, so I could do something like iron 2 plus oxygen. Here's what you have to notice. It seems very simple and easy right
I need the
now.
following juniors to report to the cafeteria with their Chromebook and something to write with. Maddie Ayers, Braden Bishop, Hayden Browning, Caitlin Klein, Shay England, Michaela England, Perry Hall, Brad Harold, Kenzie Hatfield,
So,
Diane Justice,
doesn't matter, it's still.
Tyler Rainey, and Jayla Lawrence. Report to the cafeteria with something to write with and your Chromebook, please.
So we look at this, we break this down, iron and oxygen. So what you have to notice is we're dealing with a metal and oxygen. Metals and oxygens combine to make metal oxides. So we're going to make iron 2 oxide. This will be Fe plus O2 goes to iron 2, Fe2 plus, O2 minus, 1, so FeO.
I really like saying that, FeO, PO, if you would.
So then we got a balance. So I got 1 iron and 2 oxygens on the reactant side, 1 iron and 1 oxygen on the product side. So hopefully you can see now. Need to stick the 2 here in front of the iron 2 oxide. Changes me to 2 irons and 2 oxygens on the product side. So I need a 2 here in front of the iron to give me 2 iron.
Sweet.
Good?
Yes.
So I don't want to catch you off guard. I want to give you a feel for what this will be like whenever I actually start giving you problems with these. So I want to give you a little word problem. So this is kind of what it'll be like, okay, wording wise. Something around Mr. Hall forms a synthesis reaction with 82.6 grams of iron 3 with excess oxygen. Give me proper chemical equation for the this reaction. I'll give you a second, let that write that down. I don't know if it'll let you write it down, you're gonna have a heart attack.
What's always the equations?
I will go ahead and tell you, this is like a prop op kind of thing here. It's not too difficult right now. I'm throwing stuff in here to confuse you. I'm throwing stuff in here to leave you lost, all right? So all of this is thrown, some of this is thrown here just to snag you up and catch you, all right? That's all I'm doing. Don't get caught up on this information. Where you're at right now is chemical reactions. The important information you need to take from this, Mr. Hall performs a synthesis reaction. This is important. Synthesis reaction is important because now I know what type of reaction it is. Two things are going to combine to make one thing. Enough said. With 82.6 grams of iron 3, okay? Iron 3 is important. Iron 3 is important because that's my first reactant. With excess oxygen, there's my second reactant. Why did I not underline the 82.6 grams of iron 3? It doesn't matter. 82.6 grams, that comes in when we do stoichiometry. Right now, it doesn't matter. I'm doing this now so that I don't confuse you later. I'm trying to lay some groundwork. Mass doesn't matter right now. The fact that I said excess, all excess means is I have plenty of it. So it's there.
Do we assume one?
What is it?
Do we assume one
One what?
oxygen?
No, excess means I have however much I need. Because what you're going to find out when we do stoichiometry, there's something called a limiting reactant. So it's the reactant that literally limits how much of the products can be made. It's like if I looked at you and I told you I have 20. If I looked at you and I said I have 5 bicycle tires and 20 bicycle frames. How many bicycles can I actually put together that you can ride? Why? Yeah, but I got tons of frames. What's the limiting reactant? My tires. All I'm doing right now is foreshadowing. I'm going to do it a ton through this so that I'm trying to lay a foundation so when stoichiometry comes, it doesn't kick you in the face. All right? So you pulled the important information from here. So we know it's a synthesis reaction, so it's A plus B goes to AB. So I have iron 3 reacts with oxygen. So that's a metal and oxygen. What do metals and oxygens react to make? Metal oxides. So we have iron 3 oxide.
Yes.
So I got iron plus oxygen, which is O2, so it's diatomic. React to make iron 3, Fe3 plus, oxide's O2 minus, so I get Fe2O3. Because we've done nomenclature, I'll move really quick through the whole nomenclature parts here. If you need me to slow down or you need to ask a question on why I'm getting what I'm getting for a formula, please ask me. Okay? Comes the fun part. You're gonna love this one. So we're gonna go to balance it, right? So we're gonna balance it. So I have iron and oxygen on both sides. I have 1 iron and 2 oxygens on the reactant side. I have 2 irons and 3 oxygens on my product side. Still follow your rules. Start first, balancing out the irons. So I need 2 on the reactant side, so I stick 2 there. That gives me 2 iron. But now I got a problem. I have 2 on the left and 3 on the right. There's 2 different ways you can handle this. You gotta do the fraction, but then you're gonna have to multiply out by the fraction, by the denominator, so the fraction goes away because for whatever reason, in your undergrad, they, in your early chemistry classes, do not like you to have fractions in here for the coefficients. I'm gonna go ahead and foreshadow to you, when you get to organic chemistry, they look at you and say they could care less. It makes no sense. I do not understand why. But that's the expectation. So I cannot have a fraction here. Option 2, I take the 3 from here, stick up here with this oxygen, the 2 from here, stick up with this iron oxide. Iron 3 oxide. That's the second option. Second option is the easy one. I'll go ahead and tell you the first option I explained to you, you're going to have to use whenever you do combustion reactions.
You walked in here,
Hey,
so
look,
force. Yeah.
So here's what I would do. Stick a 3 here. Stick a 2 here. So the 2 comes down up here, and the 3 comes up here. That's all I've done. Reason I've done that is now look, I've changed the oxygens, but on this product side I also changed my irons again. I love balancing. So 3 times 2 is 6, and over here 3 times 2 is 6. So I have 6 oxygens on both sides. That's why that works out so nicely for you.
What about,
But now I got 4 irons on this side, on the product side.
I don't want that.
So we gotta balance it over here. What do I gotta do here?
There's a 4.
Change the 2, make it a 4. Now we're done.
That was complex.
They are complex. They can get interesting.
In case you feel like doing it, you put where you want it to go, or it doesn't matter.
Questions?
Mr. Earl, can you do that again?
From where the people
You,
left.
Mr. Hall performs a synthesis reaction with 82.6 grams.
Why 82.6?
That's just random numbers I chose. The trick of it is, the reason I put it there is confuse you.
You gotta put your favorite numbers.
It's there to trick you up. It's there for you to look and go, oh no! Mr. Hall put numbers in this.
Yes.
0?
Yeah.
Can you guess mine?
14. 12. What was yours? There was, I think
Pretty
it was,
close.
was there 4 in it? Or just the 2?
Her favorite number is 1078.
1078.
36.
36?
Oh.
I thought you said 14. Who said 14?
Is that like
Oh, her 14.
Okay,
Kenny, this looks like a chicken scratch.
My bad,
So,
bro. I was in a hurry.
so this is
No,
what happens
some of
when this is metals
There's a word
combining with
that's
oxygen
literally
to make metal oxides.
I'll
You
tell
also,
what
on the flip side, we can have another one. This one's a little, it's easier for you because I gotta give you some more information normally.
What are you looking for?
But this is when we have nonmetals react with oxygen
Balance atoms that show up only once.
to to form.
So each side first.
You're seriously doing the notes from yesterday when we're doing notes for today?
Items that
Well,
show
I can-
up
I feel like I have to
on
know
So
the
you're gonna be
notes.
2 days behind.
No, I know the notes from yesterday, so I can understand the notes for today.
That's what it says. Balance.
This is
items that
new.
show up only once, so.
Oh, is this nothing to do with what we,
Except
what we
first.
did
I
yesterday?
may have missed a word.
The
Oh,
balancing stuff.
yeah. It's too late, Mr. All. I'm in too deep. I've got to finish this.
Dig your hole, man. Non-metals react with oxygen to form non-metal oxides.
See, people
They're
say,
not very creative, or they?
people say, you know, they're in the trenches and stuff, but who digs the trenches? They dig the trenches.
You've done this before. You just don't even know
Huh?
it. You need this in your life. You don't even know.
Oh.
Well, I just spread some absolute knowledge, Mr. Hall.
Man,
Mr. Hall,
shut up.
I have a question for you.
And ask away, Mr. Hall.
Okay? Question for you to track.
I
Use
refuse
the
to
knowledge
answer.
that has been given to you. This is like the one that I can make really complex and hard. This is about this. Mr. Hall,
My second favorite number is 3,
Good one.
and then I like
I
11.
like 36.
Synthesis.
It's just
reaction,
Perfect square divisible by 36. And
form.
vacuum tube. Yeah,
Mr. Hall.
Let's not do that. Let's not do that one. Like that. That may
Man,
be too hard for y'all right now.
no, it ain't. Put that 4 back there.
You want it?
Yeah, I want it.
Okay.
I'm ready.
Mr. Hall performs a synthesis reaction to form water. Give me proper chemical equation for this. See what you got, Mr. Atkins?
Oh,
I'm gonna give you 3 minutes to work on this,
got it.
okay?
Wait, let me write it down.
I want you to take the 3 minutes by yourself first, and then we'll go from there. Eli, how long I give you?
3 minutes.
Nice. Dale, what am I asking you to do? Oh
Same
wait, you're
question.
doing yesterday's stuff. Never mind.
No, I
Hey,
just
what am I
finished
asking you to do?
On the proper chemical equation.
Very nice. Hey Siri, start a timer for 3 minutes. These are the hard moments in my career, the complete and utter silence.
What was that?
Um, 3 minutes to yourself, Eli Chad.
Yeah.
Yeah. What's up?
Finish yet?
Yeah. I got H2O.
Wow.
Wow.
Water.
Hey, big dog, can I have a picture of the note?
Think you can read mine?
Oh, yeah, sure. Hey, other big dog. Hey, big dog.
Whoa!
All right.
Hey, Mr. Hall, it's balanced.
This is so balanced.
Yes, please.
Nobody balances equations like people.
This is all of them from today.
Absolutely.
Also check mine.
Away from me, Berman.
Push my hand
This is
up.
what's happening right now.
He's so easy.
Vernon?
That's because I
I
write.
can't tell you what's reacting. Stuff's reacting.
See, now I'm getting the notes from today, Mr. Earl, so I'll be caught up. Don't you worry.
I made it up. I made it up.
Hey, don't look at mine, I don't know what I'm doing. I know that's true.
Water, arrow, water.
Water, water.
Enough said.
You got him.
Pack it up. Going home.
Is he wrong?
Am I wrong or am I right?
You're wrong.
You said good news, they're balanced.
Alright, Mr. All, I think I see where I went wrong. My vibe was just ruined by that alarm.
All right. So this is what's happening right now.
Are hydrogen and water, oh, hydrogen and oxygen going to.
So here's what's happening. You gotta pull the important information here. So you know we're doing a synthesis reaction to form water,
Yep,
which means water is the product.
yeah,
Yep.
H2O.
So I got two things going to combine together to make me water. So I got water on the end. Well, what's water made out of?
H2O.
H2O. So
Yeah.
what two things can I take together, combine to make water?
Hydrogen.
Hydrogen
Yeah,
and oxygen.
I didn't make it this far, hold on.
So right now, the hydrogen and oxygen come close. Got a little bit of heat going.
As long as it's
Yeah.
not hot. Wait, what?
You didn't have to know about that. Anyway. So hydrogen is a diatomic, H2.
Inappropriate.
Oxygen, O2. They react to form water,
Oh, it's a dot. That
which is H2O.
stupid idiot.
You're not an idiot.
You have a diatomic.
Now, important aspect.
Now I'm locked in.
If you didn't get this, it's okay. I told you, it's challenging. So there's a challenging aspect, but here's what I do want to make sure you can get to. Can we get this balanced?
Yes.
Okay? Because right now, I'm not balanced. So how can I balance it?
What's 2 times
Throwing
1?
numbers around.
Chuck. 1,792.
Yes.
Well, you don't have to be that silly about it.
Oh,
You
okay.
can be a little more organized.
2
So-
times 1 equals 2, Mr. L.
Wow.
Thank you.
Yes.
I'll tell you what, that SAT, it's got nothing on you. I got 2 hydrogens, 2 oxygen on the reactant side, but I have 2 hydrogens and 1 oxygen on the product side. So to
Yes.
fix this, what I have to do is I gotta get a big 2 right there.
What?
Ain't nothing like a big 2, you know? You feel much better after you put a big 2
Oh, man.
down there.
I knew it was going there.
So I've changed the number of hydrogens and the number of oxygens. So we got
4.
4 hydrogens, 2
2.
oxygens
I told you. What did I say?
on the product side.
Say it again, Tanner.
2 times 1 is 2. I knew it would come up.
You put water.
Then you go over to the
Shut
reactant
up.
side, and I now have to go back and balance the hydrogens. So I have to put a big 2 right there in front of hydrogen. That gives me 4, 2, 2. Hence, we are balanced. Any questions before you get out of here?
Absolutely not. I got it. I'm ready for the test, actually.
How do you do this?
We will pick up on this
How do
tomorrow.
you always miss
Ladies and
the days
gentlemen.
when we go over something?
How do I do
I
what?
don't know, I just do it.
Here we go. We are hitting up on these chemical reactions, okay? So we're on the way with the synthesis reactions. So yesterday we talked about with oxides. Today we're gonna get into the complex ones. Gets a little complex, gets a little spicy. It's like the other thing, add a little spice. Yeah. So here we go. This one's easy. It's not too bad. All right. So this is whenever we're looking at metals and they're reacting with halogens. I want to remind you that halogens is column 17 on the periodic table. These are the ones you're probably the most familiar with. Perfect example. If I gave you something like sodium and chlorine.
There's different types of synthesis reactions, is that like metal and oxygen and then like metal and halogen, those are both.
Yep. That's like there's synthesis reactions and then there's conditions to synthesis reactions. That's what makes it hard. You gotta know what you're looking at. So in this case I got sodium and chlorine. It's a synthesis reaction, which means sodium and chlorine is going to combine to make everybody's favorite thing on the planet. Sodium chloride. Literally to the point, if you don't use this thing and you made a dish for Gordon Ramsay, he'll call you a donkey. Along with like some other language that I ain't going to use. That man needs to have his mouth washed out with soap. Like multiple times. So first off,
Pretty funny though.
I think the
you
best.
got sodium, so Na,
Still.
plus chlorine, Cl2, because it is a diatomic. Mr. Hall been throwing the diatomics at you. You gonna let me take it? Okay? The sodium chloride. So I got sodium, Na plus, chloride, Cl minus. It's a 1-to-1. So we'll have NaCl. But you know we're not finished yet. Something is wrong here. Mr. Hall had to do something. What Mr. Hall got to do?
Balance.
I must balance. Why must I balance?
Law of conservation of mass.
Law of conservation of mass. Mass of the products has to be equal to the mass of the reactants. Okay? This must be done. So we write it down. I have sodium, I have chlorine. I have sodium, I have chlorine. On the reactant side, I have 1 sodium and 2 chlorines. Hopefully you can see that, yes. If not, I say slap yourself, wake yourself up. Okay, everybody's awake, very good. The next thing we got the sodium chloride. We have 1 sodium and 1 chlorine. Well, whoopie-doo. The sodiums are balanced. But look here, the chlorines are not. You tell Mr. Hall, what Mr. Hall got to do to balance the chloride?
I gotta change them.
I got to change it. Let me change them to iodide.
You gotta do 2 of the NaCl, right? I think.
2 of the NaCl.
From the 3 notes I read.
So if I do here,
No.
well, why?
Because you gotta multiply, Mr. O. You gotta multiply the whole thing. You can't have.
That will be 2 chlorines. That's not what we do. We never can change these numbers. These numbers came from up here. I can do that. Stick a big 2 right there.
Effective.
All right, now I got 2 chlorides, right?
That's weird.
What?
That makes me feel like you're multiplying just 2 Na for some reason. I don't know why.
2 sides.
I always do it in parentheses. Would you take points off if I did it in parentheses? So I know what I'm
Yes.
doing? But Mr. Hall.
This is like 2 parentheses,
Yeah.
NaCl. You count that.
Do not put parentheses around that.
Yeah, stupid. What are you, dumb or something?
Why did you
like,
ask a dumb question like that, Eli?
Big numbers in the front will multiply with small coefficients that fall behind them. Well, Mr. Hall, how do you know the separation? Well, it's simple. Perfect example. I also changed the number of sodiums. I now have 2 of those, so I have to balance, so I have to stick a 2 here. Well, why is that 2 for sodium and not 2 for the chlorine?
Separated.
By a
Additions.
addition sign. So the addition sign does the separation for you. Okay? Dale, are you listening to me? You're playing with your pants.
I'm trying to fix something that was weird.
Pardon?
That's what I said. feel? You feel okay?
This is the easiest thing I've ever seen in my entire life, Mr.
Well,
Hall.
fantastic. Just for you, Dale. You got a synthesis reaction.
All right. Let's lock in real
Well,
quick.
you don't have to do it, it's only for him.
No, no,
So I
no.
wanna try it.
Guys, help me.
Well, I'm
Why,
gonna-
why are you still writing?
if
Why?
Oh, okay, never mind. I thought you were writing like, I thought that was one huge line, like half of it.
Well, it could be. A synthesis reaction that forms.
My mom's chem final as a pharmacist tech, in college, her like instructor just laid out different huge chemical equations and just said, okay, guys, come up here and pick one. Took her a whole weekend to balance it. She had to get help from someone and everything, like it was crazy.
That's terrible.
Sweet. All right, anyway, synthesis reaction that forms magnesium fluoride. Mr. Hall going to give you a minute, 30 seconds to yourself. Then Mr. Hall will give you a minute, 30 seconds in your group. Dale! What am I asking you to do?
Synthesis reaction that forms magnesium fluoride.
Very good, sir. Eli, how do I give you? A little louder.
I
What
think,
do you mean?
I think.
Yes,
Can you
say
say a little bit louder? What?
Hey Siri, start the timer for 1 minute and 30
Yeah.
seconds.
You fumbled that.
You said, first of all, you said a minute, 13 seconds.
So a minute 30.
Hey,
You said
hey, easy with the
13.
football terms in here, okay? We tried that one time with the interception and that didn't go good.
He's not here right now. It's
I know. Group 0. Name's fitting today. Ah! Scream back to assert my dominance. Be very careful here, okay? Mr. Hall did something he hasn't done to you before. Yes. Read the words carefully.
Troll.
What in God's green earth?
No?
Oh my dear Jesus.
Alright.
Teachers, just a reminder that your doors need to be shut and locked.
Start writing.
Oh wait, I know what you mean, Mr. Troll, never mind.
I need
I hope you caught it down, because if not, I'm gonna go out here in the hallway and cry in the corner.
Alright, you may have to go ahead and start doing that.
So we'll have to call a counselor down. Like they just don't get it, man. They just don't get it.
The only part that I don't get is the first part, and that's the most important part.
Ah! All right, now, Mr. Hall, give you a minute, 30 seconds to talk with yourselves. Don't be scared to make big, large group in here, okay? Big, large group. Here we go.
You're all
Hey
dumb.
Siri, start a timer for a minute, 30 seconds.
I don't know.
1 minute and 30 seconds, starting now.
Dale, I wouldn't be calling names.
MGF.
Just saying.
Uh-huh.
sometimes weird here.
Yeah. Wait,
Fluoride
what?
is charged as nice one.
Oh, right.
Fluoride is diatomic. Fluorine is diatomic.
Fluoride is not diatomic.
MgL2.
Yes,
Fluorine is
Only when it's
diatomic.
alone though,
yes.
not when it's magnesium
So is that
fluoride,
negative one or negative two?
because it's not alone. And also the charges equal out, so.
I did the stupid L of fluorine again.
These are the charges, right? There's two of
You
them
want
at a
to
negative one
make-
charge. Okay, so they-
Yeah.
We don't show charges.
One
Why?
negative.
So,
It's like I got magnesium metal and fluoride comes together.
it's magnesium plus fluoride.
But it is Mg plus F2.
Whenever you get to the right side, you need to care about the charges.
So it's
Oh, okay.
fluorine.
Why?
Because
Why don't
it's
you care about
not,
it over here, Mr. Earl? They
It
Because
doesn't
you're
go
putting
by
magnesium
nomenclature
fluorides
yet.
coming together.
Because
So then you gotta do the nomenclature thing and make sure you get the right formula for it.
I think they matter right here, Mr. Earl.
I tell you what, Billy, you do that. You let me know how that goes in college for you.
Okay.
I know how it's gonna go in here on your quiz.
fluorine,
I feel like you already owe me so many quizzes.
I do.
and then
I would love to like be a fly on the wall
Yes.
Like your parents pull up your
And it
grades.
would be a 2.
Looks and goes,
fluorine,
you're literally in college, Dale, passing with flying colors, and you got an F in chemistry. Wow, I haven't took any quizzes. Wow!
Separated.
Well, whenever Mr. Hall has a quiz,
Fluorine's not gonna
I
bond
get a
with
tummy
it, it's
ache
bonded
and
with
I don't show up.
Listen, I try to study, but I'm like, hey, this essay's due tomorrow. I gotta do that essay, and then I do the essay, and then I'm like, oh man, I can't study for the test because it's 4 a.m. and
You
I gotta
poor
go to bed.
baby.
I know, Miss Raw.
Can't balance life.
I know, it's terrible.
This one, because it's bonded with magnesium.
Hey,
Where do you get it?
I got
The two
two
is the
MgF2.
number that goes beside
I got two.
So you
I got
one
Mg.
magnesium,
Mg plus
fluorine,
F2 is equal
one
to.
magnesium, one
I got 2
fluoride.
Mg plus F2 is equal to M. Two
L
MgF.
fluorine again.
Yes.
I have, and then
F just looks
two.
wrong.
I can't get my brain to make that
No, only
connection.
2
I
on
agree.
this
It
side,
should be F.
because this little 2 right here, that means it's a diatomic, that's how many you have.
Shut the fish
Because
up.
it's bonded to itself,
Shut
there's
up.
2 fluorides
Yeah, but.
only on the
You
reaction
genius,
side.
Eli. Good catch.
Because on the product side, once you bond it with
You thought you
magnesium,
could guess.
fluoride's not gonna bond with
Oh my
fluoride anymore.
gosh, no, it's
It's
not.
with magnesium. So there's only
Wow.
1 on
No, you're a
the
liar.
product side.
What do you mean?
And then
Look, sodium plus
balance.
chlorine makes sodium
do
chloride.
that.
It's still a diatomic. It's still an ion.
It started with fluoride.
Yes.
Oh, alright, we're right.
And that would make
Alright,
both
here's the thing. If you're
Um,
still
No,
explaining,
don't
feel
take
free
back
to
my
explain.
and fluoride.
So we got
on the product side,
magnesium
two.
fluoride is the product. Forms is a term word, tells me
Because
that this is a product. So I've made the product. I have to work backwards.
Fluoride, which is
I have
two
a
of them.
metal and a halogen.
So
Well, how in the
you
world
have
do I
two
put metal and
magnesium
halogens
fluorides, so
together?
that's not gonna transfer over to just 2
I put the
magnesium
metal with the
and
halogen.
2
It's
fluoride.
that simple. I mean, you know, it's like
Does that make sense?
how you get the high school relationship.
That's
you
a
just
nice balance.
Have a dude ask for a girl's snap, you know, have him shot down like 3 or 4 times. Finally, a girl say yes, and then next thing you know, by bing, bada boom, the daddy. That's how it's done now, right? Yeah, something like that. I'm just kidding. Don't call me old. All right, so magnesium, Mg, plus fluorine, which is a diatomic. Can't forget those diatomics, everybody. If I had a senior quote, it'd probably be, remember your diatomics. Then, so you got magnesium, doing the whole like combining thing with the fluorine, and it forms into magnesium chloride. Magnesium comes from the second column, so now we care about the charges because now they're bonded together. Right down? Very nice. Magnesium, second column, that's a 2+ charge. Fluorine's now in fluoride, that's in the 17th column, so that's a -1 charge. Yeah? Yeah. That 2 comes down for fluorine. I mean fluoride, sorry. Well, the 1 comes down for magnesium, gives me MgF2. It's a nice thing. It's already balanced.
Mr. Roll, I've never seen what you just did in my entire life.
Yes, you have.
Why do you do that? Oh wait, never mind. That's the one thing. Okay, never mind.
But there, you would have saw it 10 minutes ago if you would have not been like playing with the hem of your pants.
Mr. All, I was trying to adjust my cuff of my.
Don't feel like you need to
sleeve
explain. We're
of
okay.
my pant leg.
We're okay. Yes, sir, Eli.
Oh, never mind, I just kind of answered that question.
Very good. All right, here we go. That's the metals with the halogens. Yeah, you know what I mean, man? Yeah, okay. I guess it's time to kick it up a notch. We're going to talk about a special case of synthesis reactions with oxides. In other words, we are no longer making oxides, we already have oxides in the reaction. she's getting on to me for a minute. All right, here's the first one we're going to deal with. This one is a special case, and this is one of the hard cases. Very difficult. We have a very special case. We have little active metals, active metal oxides, with water make a very special thing. This is where your nomenclature skills come in very handy. We make a metal hydroxide. I just want to poke my head in there right now and just scream, "We are!"
I thought she was really upset with them. I thought she was screaming at them.
Oh no, she's being sarcastic right now. I had Miss Steffi for her class. I remember one time she yelled. And it was like one of those, you ever been in one of those moments, like a weird angle thing? Like somebody's doing something and you think it's towards you, but there's a person behind you? Yeah, that happened to me with Miss Steffi. We were in a class, we was in a typing class. She did my typing class here. As I'm typing and everything. You know, been doing really good. Been knocking it out, got an A in the class. I'm like, cool, I've learned how to type. This is sweet. This is awesome. And we come in one day and she just looks and says for the next couple days, we're just going to work on makeup work. I want you to do these assignments. If you're missing something, if you're not, read a book, blah, blah. We're like, cool, okay. So I've got an A. I've done all my assignments. I'm done. I'm chilling. I can't even remember what I was doing. The next thing I know, it's like I'm over here at the front right with one person sitting to my left. And she is in the very back left, which puts her at the perfect angle that she turns. And all I hear is, "I've had enough. This is stinking ridiculous." Starts pointing her finger, start letting have it. Starts chewing up one side down the other, looks and says, "Ridiculous, you are so disrespectful. All you do is disrespect me. And here it is, I gave you this day to do this work so you wouldn't fail this class." At this point, my heart just sank and I thought, I'm failing this class. I thought I had an A. Oh my dear God. What am I going to do? So I'm sitting there and I'm like looking at her and I'm like. And then she says the name of the person sitting next to me and I go, "Oh, sweet God. Oh, thank you, Jesus." Oh, I'm telling you, man, I should have went to church. That's that type of thing. Anyway, so active metal oxides with H2O will make metal hydroxide. I'm going to tell you, this one is hard. This is the reason this one is hard, is you have to know what active metals are. I'm going to make it very simple for you what active metals are. There are columns 1 and columns 2 on the periodic table. So the first one of column 1 is the alkali metals. The second one of column 2, those are the alkali earth metals. I will tell you this, to preference this for AP chemistry, because you all are signing up for that, and I know we'll have a wonderful time next year. Please God. This makes strong base. Anyway, let's go to the reaction, man. Okay, perfect example of when we look at this. If I looked at you and I told you that there was a synthesis reaction of some calcium oxide in water. This is where the magic comes in, ladies and gentlemen. You're gonna show your skills because you get a look and say calcium oxide. That's a strong, very active metal oxide. Easy to do. Put some water. It's gonna make a metal hydroxide. Well, what metal do we got going on here? We got the metal, as a translation of the metal of calcium. Calcium is the metal, so we make calcium hydroxide. I don't know why I put a little stick on it. I drink more coffee than I normally have. I honestly feel like I could bust through a wall right now. I better not though, we got visitors today. Oh man, what if they came in today? Oh gosh. Oh yeah, you can wait. So calcium oxide, you look at calcium oxide, we're gonna get this thing down, it's Ca2+. It's 2+ because it's in the second column. 2+, right Dale?
Yeah.
Yeah. Then we got oxide. Oxygen comes from the 16th column, that's a 2 negative. Right, Eli? Yeah, that's a 1-to-1 ratio, baby. I'll tell you what that means. We simplify that bad boy out, it's just gonna be a CaO. Right, Rose? Yeah, you bet. Now, we got the water. The water, the dihydrogen monoxide, also known as H2O. As Bruce Lee once said, be water. Your inspirational quote for the day. Now we go to the calcium hydroxide. Mr. Hall is trying to check your nomenclature skills right there. You want to know why? This is tricky. Break this bad boy down. You look at the calcium. The calcium is a 2+. Comes from second column. Right, Aiden? Yeah. Yeah. Hydroxide is one of your favorite things, the polyatomic ions. I know you love them. Save your recycling. OH! Negative. Can't stand the Buckeyes. Okay, so the 1 comes down, the 2 comes over. Yeah? What, do you like the Buckeyes? Hate the Buckeyes. That's my last nerve, man.
He said, no.
CA, we got the 1 come down. But then here's the cool part. We got OH. But there's a 2. I need 2 hydroxides, which means I got to have the parentheses. Hey, Dale, this is when you do use parentheses.
Ah,
Yeah.
that makes sense.
Let me erase this a little bit so you don't get confused. Good Lord. There we go. That's better. So we got to put the 2 around it. Yeah? Okay. Now we check the balance. I have calcium, I have oxygen, I have hydrogen. Why did I break it out? I know I told you, polyatomic ions lead together. But hydroxide shows up on this side, does not show up on this side, so we have to break it apart. Okay? Okay. Well, first off, on the reactant side, I have 1 calcium. I have 2 oxygens. Do not let me trick you. Catch the 2 oxygens. You see the oxygen with the calcium oxide and the oxygen with the water. Okay? They are separate, but there are 2 of them. I have 1 from here and 1 from here. Any questions? Okay. Hydrogen, I have 2. Very nice, yes? Very nice. I like that. Now we go to the product side. Somebody tell me, how many calcium?
1.
Very good. Somebody tell me how many oxygen. Wait, I almost died. If I died, you still wouldn't get AIDS.
No, we told you can't die.
They could embalm me and I would come back to life.
You would look around like.
Like Jesus said that all my kids was about to get AIDS. I'm back. How many oxygens?
Boom,
2. How many hydrogens?
boom.
Very good. The 2 on the outside of the parentheses. You multiply that by the number on the inside. They both have 1. 1 times 2 is 2. I prepare you for SAT. Yeah? Very good.
I can multiply now.
Woo! Teach it math too. Let's go. Boom, baby, boom. There we go. She's already balanced. How you feel about that? Huh? You tired? What you tired for? Can't be tired yet. Yeah, let me be tired. This like first class of the day. Tired.
Yeah, it's not looking good.
Tell your rest of your people that they're welcome, that I got you away.
The rest of my people.
Yes, your people.
Who are my people?
People that get you.
Oh,
Who are
my people. I was like, do I have a tribe of people?
You don't? I do.
No, I'm a local.
Tribe of Hull.
She wasn't my tribe. Yeah, I was part of the City Cochran tribe. Sydney's leaving, so I had a leadership there.
Hey, Mr. Hawk, got a question for you. I want a synthesis reaction
No. What? Another synthesis?
to make
What?
potassium
Oh, is this?
hydroxide.
This is an example.
Mr. Hawk, give you a minute and 30 seconds. Aiden, what I asked you to do?
Make a photosynthesis reaction.
Very good. I liked how you sounded like a water boy there for a moment. That was very
I'm not
nice.
ready.
I enjoyed that. Sydney, how long I give you? Very good. Hey Siri, start a timer for a minute and 30 seconds.
1 minute and 30 seconds, starting now.
Are you okay?
I feel great.
You look like you're about to explode.
With excitement. Don't worry, if you hear a chair go in the hallway today, it's probably just excitement. Ah-cha-cha.
It makes you nervous when you watch me and I can't do my work.
I'm sorry. You just caught my attention because it's like you wrote on this side, then you write on this side. I never saw that before.
Sorry.
Threw me off for a second. I was like, wait a minute, did I see that correctly?
Okay.
Mm-hmm.
Bam, bam. Bam,
Thank you,
bam,
ma'am.
Bam, bam.
Yeah. Why you got 2 arrows?
They just, I don't know, maybe
Put it back.
it tells me it goes both ways.
Yeah, we're just gonna go the one.
Wait, it doesn't go, well, I mean, I don't know.
It can. We're not in
Okay,
AP
okay, yeah,
chemistry.
yeah. Okay. But anyways, how do I know it goes over here?
Huh?
How do I know it goes over here?
Well, what is this?
So is it K plus OH or K plus O plus
So that
H?
is a metal hydroxide, that's active metal hydroxide. Very important, active metal hydroxide. So active metal hydroxide forms from what?
Water. So we need water, you need H, right?
Oh yeah, we definitely gonna need some of that. We're gonna need something else too. You see that heading over there, synthesis reaction with oxides that
Oh.
underline the active metal oxides with H2O make metal hydroxide? The answer's right there.
So water, the H2O.
You need that, but you need something else.
With
I
metal,
said that, I'm a little
with
scared.
metal
I'm a
hydroxide.
little skeptical.
What?
Active metal oxide.
You have to.
Active metal oxide. So what's the active? Hey Siri, start a timer for a minute 30 seconds.
What is the active, what is an active metal oxide? That's the thing in the first 2 columns, so that.
Hey, do you not listen
But I
to
already
me?
have it, it's potassium, right?
I'm happy. You can do the nomenclature on the right side, but you're gonna do the whole thing now. Okay? Look. Active metal oxide with H2O make metal hydroxide. Water
During Bible study at 7.
Okay, with water. What comes before the with? Active metal, active metal oxide. So you got that right. The potassium is the active metal, but you have to make it an oxide. So it's potassium oxide.
That's weird, Mr. Roll. Okay.
Well, if you like his and you like
It's
Rich.
a little weird that you did like, HO instead of OH, but that's okay.
That's so true.
You know, it's okay. You're just a biology person. It just makes me like you a little less.
Don't understand that.
Okay.
Biology.
Biology is the worst.
Biology's okay. Chemistry's better.
Well, biology sucks.
Oh, you're supposed to be copying it first.
Oh, no, you don't.
Hang on.
What do you got so far?
Hang on. I got KO plus H2O is equal to
I
KO.
know.
But I,
Potassium has a charge of 1.
oh, the
Oxygen has a
charge.
charge of 2. So it's going to be K2O.
Yeah, the charge. I forgot about the charge. That's why, there we go. So KO,
K2O.
hang on. Pause. Negative one, or positive 1. O, 1, negative 2. So therefore, 2K2O plus H2O is equal to that. So then we have K2, plus, we have 2K2O to that, so we go pink.
Don't put in parentheses.
Anyway, that's right. Okay.
All right, Mr. Hollister.
So, active metal oxide. Okay.
Here we go. Synthesis reaction to make the potassium hydroxide.
And
Here's how I break this down. Potassium hydroxide. So I have hydroxide, but this is an active metal.
Comes 1 and 2.
If I'm going to make an active metal hydroxide, I know that means I must have an active metal oxide with water. Right there? Yeah, very good then. So active metal hydroxide. What's my active metal?
Oh, potassium.
Potassium, okay? Okay. That's the chemical symbol, okay? Okay. So I have an active metal oxide, potassium oxide. So K plus 1 charge. I have the oxide, comes the oxygen. So 2 negative. You capiche? Very good. The 2 comes down for the potassium. The 1 comes down for the oxygen. I get K, 2O. Good? Any questions? Okay, I combine that thing and I slap it in and mix it up with some water. You know, that high quality H2O. Yeah! Whenever I do that, it goes bang! And it pops out some potassium hydroxide. And by pops out, I mean puts it in a solution. So now I got a base. Potassium hydroxide, that's K plus and OH minus. Alright, that's a 1-to-1 ratio. So K, OH. Okay?
No, it's more like a cup.
Oh, okay, cool. There you go, let's balance. Potassium, oxygen, hydrogen. Potassium, oxygen, hydrogen. On the reactant side, I have 2 potassium. How many oxygen? Good, don't let Mr. Hawk trick you. The oxygens are separated. There's 1 there and 1 there. Okay? 2. 1 plus 1 is 2.
Wow. I know how to do addition now.
You tell your math teachers that they're welcome. How many hydrogen?
Not 2.
Also 2.
Oh, very nice. Like somebody took a big 2 over there. Just loaded down with little 2s. It's like boom, boom, boom. That was a poop joke if you didn't get it. The right side. How many potassiums? How many oxygens? How many hydrogens?
One.
My wife looks at me and is like, you should not say stuff like that, Kevin. Truth of it is, my wife's probably right. I probably shouldn't. The worst part is, it's on camera. Poop jokes are funny though. We gotta balance it. What I do? Are they here?
No.
What?
Oh.
Oh.
Wrong side.
And they oh.
No.
Oh.
What the?
Not there either.
Transforming.
I'm turning into the Hulk. Ah! This is a lot slower than on the movies. I'll put a 2 here.
Sure. Wow.
Mix all those 2s, and I'm gonna throw this thing away so that I don't ruin my pants or my shirt because my wife can kill me.
With the concussion.
How you feel about that?
Good.
You feel good? I'm happy you're feeling good. I'm not right now because I feel like I'm going to end up with it. What, Eli?
I have a question. It's not related to what we just did at all, or a little bit. So hydroxide is a polyatomic, right?
That is correct.
So it can be an oxyacid. How would you ride that out? What would be the name
Of hydroxide?
as an acid?
Of what? That's a base. It's not an acid. Hydrogen's not first.
But say you put hydrogen.
Then you're doing something different. You're not making.
Then it's me.
If you put hydrogen first on that, I'm going to like croak.
What makes-
Potassium should always come first. Like you put KHO, and I'm like, that's okay.
What if I put HOH?
Why would you ever write water like that? Good news for you, Mr. Hall. Will see you tomorrow where I will teach you how we will make oxyacids.